I'm going to run through just some select problems, see how we do. So number 2 I should do the evens. They give you the equation is y equals x minus 2 quantity squared plus 4. So this is vertex form, so this would tell us that our vertex is 2, 4. Yay? And then they want us to put it in standard form, which is also sometimes called standard form or called, I forget what they call it, general form. So standard form means, hey, we would need to multiply this out. I think it's 157. Yes, 157. So if I multiply this out, I get x squared minus 4x plus 4 plus 4. So then it gives me x squared minus 4x plus 8. I think I did that right. And then we have to see if we can factor it. It's not going to factor. Is it? Won't factor it. I can't multiply two numbers together to get 8 and add them together to get -4. I mean, 4 and 2 is not going to work, and 8 and 1 is definitely not going to work. So it's not going to factor. So it's in standard form as is. This in standard form is going to tell us that our y-intercept is at 0, 8. And if it doesn't factor, what's the go-to to figure out the roots?
Find the roots.
Can't find the roots. How?
Oh.
Yeah, quadratic formula. So x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. And plug your values in. So I get -4 plus or minus -4 squared, which that's going to give me a positive 16, minus 4 times a times c all over 2 times a. So that's going to be 4 plus or minus 16 minus 32 over 2. Oh, shoot. 4 plus or minus the square root of -16 over 2, which means you do not have a real solution. It doesn't cross the x-axis. Yeah, that's a shame on them. Okay, so you really can't find the roots because there aren't any real roots. All right, let's see. Can I go to number 4? Number 4, we have y equals x squared minus 12x. Minus 28. They want us to factor it. So at this point, when you have your x value, or your x squared value is 1, sometimes you can go through and say, okay, what two numbers multiply to give me -28, add to give me -12? That would be -14 and positive 2. Okay? This right here gets me the y-intercept at 0, -28. This gets me the roots. So the roots are going to be at 14, 0 and -2, 0. I could find halfway in the middle of those two to find the vertex, or I could find the vertex by doing -b over 2a and then plugging it back in. So I get -b, so I get -12 over 2 times 1. So that's 12 over 2, which is 6. So I get 6, something. So if you plug that 6 in, let's see, that's going to be 36 minus 72 minus 28. Let's see, 36 minus 28, that's -8. So -80? Ew, that's our vertex. Yikes. I guess we won't be graphing that one. Too long to count. So 6, let's go to number 8. I'm skipping around a little bit. Number 8 looks like this. You have y equals 3 plus x and 3 minus x. So it's a little backwards, but it is factored form. So they want us to find the standard form. So if you multiply this out, you're going to get 9 plus 3x minus 3x minus x squared. Those cancel. So, and then I can put it into a descending order with the exponent. So I can get that. So that's my standard form. That'll tell me my y-intercept is at 0, 9. And then my roots are at 3, 0 and negative 3, 0. I set those equal to 0. And then my vertex, if I go negative b over 2a, do I have a b value? B goes along with an x. I don't have an x, do I? So it's got to be 0. So if I plug 0 back in, I get 0, 9. And that's what my vertex is going to be. Cool? All right, I'll flip the page. Let's see, 10, 12 we're okay with. Let's go to 14. Let's go 14, is that okay? Number 14, they tell us that we have a vertex at 3, 3. And then we also have a value at 6, 12. So you have some point at 6, 12. So let's use some logical thinking on this one. So I had 3, 3. I'm right here. And then at 6, 12. So 4, 5, 6, and then 12. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you have that point up there, which would mean if I went 3 this way, I'd get 3 over this way. So that's up at 12. So I have to somehow use this equation to figure out what works. So my h and k values are 3 and 3. So, but if I wanted to find my a value, the a value dictates how pattern graphs. So let's think about this. If I go right 1, up 1, and left 1, up 1, are we kind of heading towards that? And if from there I'm going to go right 1 and up 3, and left 1 up 3, and then if I go right 1 up 5, it works. So my a value has got to be what? 1. So the 1, 3, 5 works. So 1, x minus h, my h value is 3, so x minus 3 squared. My k value is 3 as well. Oop, 3. Because that's h and k. Okay, so I just had to use a little logic to figure out, does my pattern graph work? Usually the pattern graphing in here, your a value is going to be 1 or 2 or negative 1 or negative 2. Usually. But just use some logic. I'm not going to give you an a value of like 2/3 or 721. Man, I'm counting like crazy. What do you think? Is that okay? All right, so that was 14. Solve by factoring, we're okay there. 20. We're just going to go to 20. They want us to use the quadratic formula on it. So number 20 says you have 2x squared plus x, and it's equal to negative 1, so I'm going to bring the 1 over to get this. Now I have to go x is equal to negative b plus x squared, negative b squared minus 4ac all over 2a. And that's going to give me negative 1 plus or minus 1 minus 8 over 4. Negative 1 plus or minus root negative 7 over 4. What does this mean? No real solution. Yeah. Come see me. On 16, all I do is add 80, divide by 5, take the square root. Plus or minus 4 is your answer. The last one I want to look at is number 22. So number 22, it says that you have this equation. They're calling it h at t equals 12x minus x squared. So this is an upside down parabola. So it says the front of this store has an arch that's a parabola. Is that parabola open down? Should the parabola with our equation open down? Yeah, because the negative x squared says it's opening down. So let's figure out a couple things here. I think I could just factor this. I can get x and then 12 minus x. Set those both equal to 0. So I'm going to get x equals 0. So my roots are at 0, 0, and at 12, 0. So let's think about what this means. Here's 0, 0 right here. And then 12 zeros over here. Agree? So let's figure out the vertex. So if I start finding the vertex, I'm going to go negative b over 2a. Or I'm going to find halfway between 0 and 12. What's halfway between 0 and 12? 6. So this is halfway. But if you're like, oh, okay, I don't really buy that because you have this negative b over 2a. Well, my b value is 12, so I get negative 12 over 2 times my a value. So that's going to be 2 times like that. So that's going to come out to be 6 comma something. How do I figure out the height of this archway if I have the x value? The y value is the height. How do I find the height? What do you think? Stare at it and it'll change?
Yeah.
Notice my original equation. What's my original equation say? Does it say y equals? No. No, it says h at t. So h at t means height. So how am I going to find the height of my vertex? Plug it in. Good. So you get 12 times 6 minus 6 squared. So that's 72 minus 36. Did I do that right? Yep. So 36 is going to be my total height. So the tallest point from here to here, that's 36 feet. This opening is 12 feet wide. Agreed? Yes. So we're just using some logic where this might apply. So how high is the archway at its peak? 36 feet. Sketch the graph. Got it? I guess we could do this. 36. Oops. Make the dot bigger. Cool. All right. How wide is their object at the base?
12.
12, okay. So if you had a box, if you had this rectangular box and you can't tip it over sideways because it's like full of water or something, that is 8 feet wide and 22 feet tall. Will this box fit through this archway?
Yes.
Right. Prove it.
Oh, it will not.
I feel comfortable saying that this box this way will fit through without a problem. Okay, and that happens to be 8 feet wide. We're dead center, so I'm going to go 4 on each side. So this is 2 over here, and this is 10 over here, right? So it's going to fit through at the base. You're like, oh, it's going to fit. But this up here, this value here and this value here are the exact same y component. Are those two areas of our parabola more than 22 feet tall? How do I know? What do I have to do? What value am I finding if I have an x value of 10 or an x value of 2, which yield me the exact same y value? How do I find out what the y value is going to be? Plug it in. Okay, what's easier to plug in, 2 or 12? Doesn't really matter, both kind of easy. So I get 2 times 12 minus 2 squared. So that's 24 minus 4. So right here, this is at a height of 20 feet. That's at a height of 20 feet. So will our 8-foot by 22-foot tall box fit through this doorway? No. It's wide enough, the doorway's wide enough, but it's not tall enough. So won't fit. Find a different way. Cool? What do y'all think? All right. If you need a calculator, come grab one. One of these is actually dead, so when you grab yours, make sure it's working. Or if you have your own graphing calculator, bust it out. It's not a quiz. Notes. But we're working with stuff on the calculator today. It's, you'll be able to do it all by hand if you don't learn it on the calculator. I'm going to kind of go quickly just so you see that how it works. He was taking an AP test today.
There was an AP test in
Make sure your calculator's working. Turn it on. Make sure it's working. If it's not working, I'll get a different one. All right. Let's run through these notes a little bit. And this is kind of some real-life application where you might see parabolas. So they give us the first equation down below. They tell us that we have this rectangle that is bound by this quadratic formula. Okay, so we have this rectangle. Things I know about a rectangle are length and width. In order to find the area, it's length times width. But they tell us that this times length times width in this category works. Oh, I'm sorry. Okay, so we want to use the calculator to find the maximum area of the rectangle. So does this parabola open up or down? Down. How do you know? Negative x squared, right? The a value is negative, so it's going to open down. So I'm going to switch over to the calculator a little bit, and I'm going to show you how to clear some stuff out. So if you turn your calculator and you have stuff here, just hit clear. Just knock it out. Okay? And then go to y equals, and we're going to, if you have anything plugged in, hit clear. If any of these plots are on, so if it looks like that, it's highlighted, move your arrow up to that. It'll blink on top of it, hit enter, and it'll turn your stat plots off. That's the dead one? Sure. Man, I really didn't count well. All right, so we want to use the calculator. We're going to use the calculator as a tool to do this math for us. Okay, so I'm going to plug in negative x squared plus 6x plus 27. Okay? Now, if I just hit graph right now, I have no idea what this graph's going to look like. Oh, I can barely see anything. My window's all out of whack. So if your window's out of whack, hit zoom, and then because we're doing just a thing, go to zoom fit. So you have to use arrows, hit enter, and it's going to change your window a little bit. You're going to see a little bit more. Each calculator is going to be a little bit different, but that's okay. So does it look like I can see where the vertex would exist? And if a parabola opens downward, is the vertex a maximum value or a minimum value? So opening up and opening down, is the vertex minimum or max? So max. So we want to ask the calculator to find us a maximum value. Okay? So from there, you're going to go second trace, which is calculate, and look at that. It says maximum. What do we want to find? We want to find a maximum. So you're going to go to number 4, and you're going to move your cursor so you can go to the left side of it and the right side. So does it appear that my cursor would be at the left side of where my vertex would take place? Once you get there, you hit enter, and then you're going to move your cursor to the right side of where you think your vertex is going to take place. Does it appear that I'm on the right side of my vertex? So I'm on the left, so the highest point is in between those. Do we want to guess? No. I'm just going to do it. Hit enter one more time. So I think our vertex is actually at 3. I mean, I know they have it as 2.99. The tolerance on the calculator might be off a little bit. So I would say that my rectangle has an x value of 3. My rectangle, bound by my parabola, has a maximum area of 36. You see where I got those values? 3 comma 36. That's my vertex. So let's go back to our original problem. So we found on here that we have 3 comma 36. This is my maximum area. So 3 has to either be length or width. I don't care which one it is. Pick one. So I'll make 3 my width. So I know that area is equal to length times width. So area is equal to 36 is equal to 3 times L. So what does L have to be equal to in order to get this maximum area? 12. Okay? Did it ask us to do anything else in there? Calculate the roots by hand. Oh, we could do that. Okay, to find the roots by hand, let's do this. Let's actually use the calculator to do this. Oops, back here. All right, so does it appear I can see where it's going to cross the x-axis up here? Does it look like I can see it? If your window's goofy, maybe you zoom out a little bit. So zoom 3 and hit enter. And so then, now it looks like I can see it. I don't need my window to be quite this big, and I'm just going to modify it. Negative 10. Max is 100. I don't know if I got it that big. I'm going to go with 50. Let's go like negative 10. And my maximum is 50. And graph. So I just changed the window a little bit. Okay, so that's my parabola. This is my x-axis. So if I wanted to find where it crosses, I'm looking for a root. And a root is another name for a x-intercept, which is another name for a 0. Okay, so if I want to find a 0, I can use the calculator for that. So I'm going to go back to second, calculate, and I want to find a 0. And we notice that 0 is one of the things up there. Great. So we're going to hit number 2, and we're going to take our cursor, and we have to go to underneath our line. So see our cursor? I want to find both of those zeros. So it's going to find one at a time. So I have to get my cursor to be underneath. So it's underneath. And then I have to make it go above it. And above my x-axis. So do I want to guess at my value? No. So it looks like my 0 is negative 3 comma 0. Now let me ask you this. Do I have a negative length I can call out? You go and measure something, and you say, hey, what's the length of that? Can you say, hey, it's negative 3 inches? No, it's ridiculous. You're not going to have a negative length. So this 0 here is a solution that doesn't work for us in the context of our problem because we're dealing with lengths and widths. So now I want to find my other 0. My other 0 is right there. So we're going to do the same thing. I'm going to go second, trace. I'm going to find the other 0. Now I have to move my cursor over on the other side. So this way, because I'm going this way, I need to be above it and then below the x-axis to get that 0. Do I want to guess again? No, I want to know. So then the other one says, look, 9 comma 0. Okay? So I found my 2 roots, one to be at 9 comma 0 and one to be at negative 3 comma 0. So this would have yielded me x minus 9 as a binomial. Agreed? Because if I said x minus 9 equal to 0, I'd get 9. This yields me what binomial? X plus 3. Good. And so if I were to multiply x plus 3 and x minus 9 together, I get this. But we'll look at that. We have a negative out front, so we will have to modify it a little bit. So I would actually probably modify it like this. Probably go negative x plus 9. Now if I multiplied it, negative x times x is negative x squared. X times 3. Oh, this one should be the negative one. That should be the positive one. Now it's going to work out. Okay? And I'm not going to give you something that complex, but that's what's taking place with this problem. Let's flip to the back side. On the back side, it says the area of a rectangular garden is represented by the function x and then 10 minus x. That's the length and the width. Use a calculator to find the maximum area. Okay, so on the back, we have f of x is equal to x by 10 minus x. Use a calculator to find the maximum area. Do I have to multiply this out to plug it into the calculator, or you think that the calculator will understand a monomial times the quantity binomial? Well, let's take a look. Go here. X minus 10x, right? Y equals. I'm going to clear this one out. I don't want it anymore. I want x parentheses 10 minus x. Close parentheses. Okay, if I distribute it over, that'd be 10x minus x squared. So if I had zoom fit, which is zoom 0, I can see that, and I might want to maybe, there's some cool things we can do. Well, we can do with this. And let's just zoom out. Zoom out. Window. I don't need these maximum, unbelievable huge values for y. Negative 10. Y maximum. 100 maybe. Graph. This might look a little better. I don't need to go so tall. I'm going to change my window again. I don't need that tall in my y direction. Let's go with, I don't know, 15. Graph. And we can bring it in on the x direction. So I'm going to go negative 10 to positive 10. Graph, see if that works. Almost there. Change my window just a little bit more, maybe change it out to 15. Graph. And then I can't see my max anymore, so I'm going to go maybe up to 30. See what happens there. Yay! I can now see it. So I just manipulated my window a little bit. Okay? And I know I went kind of quick. I'm just trying to show you this. So use the calculator to find the maximum area. So the maximum area is going to be this vertex. So let's see. I need to find a maximum value. So I'm going to go second, calculate. I want to find a maximum. I need to be on the left side of it. Yep, I'm on the left side. Move my cursor over to the right side of it. So 5, 25. 5, 25 is my answer. So 5, 25, that's my vertex. So my garden is going to have a max area of 25. Okay, that's if I have one of my lengths being 5. Draw a diagram to represent the vertex and parabola in the context of the problem. Okay, use the unit of measure. Rectangle is feet. Find the perimeter of the rectangle and maximize. Okay, so I have 5 by length and I have an area of 35. So I know 5 times length equals 35. So length is equal to 7. So if I want to find the perimeter, 5 plus 5 is 10. 7 plus 7 is 14. 14 added to 10 is 24 feet. Maximum area 25 square feet. Squared. Okay. Calculate the roots of the function. I don't know. Let's take a look. Let's look at the roots. Looks like 0, 0, and if I just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0, 0, and 10, 0. Those are my roots. 0, 0, and 10, 0. How can I verify these are correct? Oh, I'll just set this equal to 0, so I'll get x equals 0, so that's 0, 0. And 10 minus x equals 0, so that's 10 equals x, so 10 comma 0. The roots took place both ways. Pretty cool. So it actually applies to some things. I know you're going to get the kid, I don't ever want a garden, I'm going to live in an apartment for the rest of my life, I don't care. I get it. Just trying to show you some places you might see this type of math. So for tonight, all I simply want you to do is I just want you to try, because I know it's brand new, I just want you to try page 161 1 through 5. Just try it. I know some of you might not have a calculator at home. You might be able to get on there and try it and have some fun. I need all the calculators back up here, though, please.